Hello, this PSA on solar energy is brought to you by Quincy, Greene, and Andrea, Carey. I'm Andrea, Carey, and Quincy will be joining us later on in this video. Today we will be talking about what is solar energy, how and when it was discovered, how do solar panels work, what are the costs of generating this alternative source of energy, how much power can be generated, especially in comparison to other sources of electricity, what is the time frame to implement this kind of electricity, how much land this electricity would use, the current technology and R&D, and the current pros and cons of using solar power energy.
Solar energy, also sometimes called photovoltaics, is the process of converting light from the sun into usable electricity at an atomic level. The photoelectric effect was first noted by French physicist Edmond Becquerel in 1839. He found that certain materials would produce small amounts of electric current when exposed to light. In 1905, Albert Einstein described the nature of light and the photoelectric effect on which photovoltaic technology is based. He later won a Nobel Prize in physics for this discovery. The first photovoltaic model was built by Bell Laboratories in 1954. It was built as a solar battery and was mostly just a curiosity, as it was too expensive to gain widespread use. From 1938 to now, solar cells are being used in a variety of small-scale scientific and commercial applications, but due to how expensive they are not as widely available as people would hope. As mentioned in the previous slide, some materials exhibit a property known as the photoelectric effect. This means that the material absorbs photons of light and releases electrons, which are high energy. A solar cell is simply produced by using a piece of semiconducting material that can produce a photoelectric effect and create an electrical field which has a negative charge on one side and a positive charge on the other. When light hits the solar cell, electrons are released from the semiconductor. If electrical conductors are attached to both the positive and negative sides, the circuit is completed and the electrons are captured in the form of an electrical current. Multiple cells are placed together to create a panel, and these panels can be designed to supply electricity at a specific voltage. The current, however, is simply dependent on the amount of sunlight that strikes the panel. The problem with solar cells is that they're not 100% effective due to some refraction of light. Some of the light spectrum, such as infrared, is too weak to create electricity, and some of the light spectrum, such as ultraviolet, creates heat energy instead. The average solar panel output ranges from about 175 watts to about 235 watts, with an exceptionally powerful solar panel measuring at 315 watts. Among the top 10 manufacturers, the average wattage of a panel is about 200 watts. As sales price goes, one report in 2012 indicates that the median install price of photovoltaic systems was $5.30 per watt for residential and small commercial systems smaller than 10 kilowatts in size. For commercial systems more than 100 kilowatts in size, the median price was $4.60 per watt.
As far as cost goes, and total savings versus costs, there are a lot of things you can do to save money whenever thinking about installing. In the top left corner, you have the total savings that you can have based on a 25-year time span. Next to it, on the right side, you have the total amount of cost it takes to install and upkeep those panels. Underneath that, you have the incentives that are currently offered. Now, over a 25-year span, that could possibly change, so that is still debatable. But as far as how much electricity and how much you would save on your bill, there's obviously a great savings whenever it comes to money on your bill. Whenever it comes to how much you have to pay each month on your electric bill, you're saving a lot. And not just in money, but environmentally as well. Now, when you compare the cost of solar power energy to other sources of energy, it's actually one of the highest costing forms of energy out there. The only other one that is even close to it is wind energy. As far as how much solar power energy we use in the United States, we actually don't use that much solar power energy. The reason for this is because of how much it costs. Now, there are other forms of environmentally friendly sources of electricity out there. It would just be beneficial to implement solar and wind due to their low emission rates.
As far as time frame it takes to implement this kind of energy, the total installation time for a standard 3 kilowatt solar system of about 20 solar panels is somewhere between 1 and 3 days. The average labor time is 75 man-hours, which can be further broken down into electrical installation labor, which is about 49 hours, and non-electrician installation labor, which is about 26 man-hours. The time from you deciding to go solar to actually installing the panels up on your roof can take longer. The design of the solar system and other lead-up work adds time to the process. In most places, you're looking at a couple of weeks, but depending on the region and how long it takes to get permits and how developed the solar market is, it can actually take several months. The complexity of the solar system can lengthen the installation process. A solar system with a battery backup is more complex and will add a couple of hours to labor. Compared to other sources of energy, however, this is a very quick time frame in order to install an alternative form of energy.
Hi, my name is Quincy Greene, and I am on a team talking about solar power with Andrea and Carey. So the first part that I'd like to talk to you about is land usage for photovoltaic cells from a residential perspective. In order to calculate the size of a photovoltaic array, first you need to know the average daily sun hours, the peak sun hours. At what time is the sun shining the most? On average around the United States, there's about 4 to 5.5 hours. So we'll use 5.5 for this example. Next, you need to calculate your projected annual energy consumption in kilowatt hours by 365 days. So this gives an average daily consumption in kilowatt hours. Then you divide this amount by the daily peak sun hours to get the approximate array size in kilowatts. So let me give you a quick example. Let's say you use 6,600 kilowatt hours a year. Divide that by 365 days, and you get about 18.1 kilowatt hours per day. Then you'll divide that by 5.5 sun hours. That's the peak sun hours per day. You'll get about 3.3 kilowatts. Then you're going to divide that by the system's efficiency factor, which in this case we'll use 0.72. That will give you about 4.6 kilowatt array. So then you'll know what size to purchase. And for this example, you'll purchase a 4.6 kilowatt photovoltaic array. Now if you notice, in the background, there are bicycles that people can rent per day, and next to it is actually a photovoltaic array that powers the system and the stands that control those bicycles. Now in terms of large-scale commercial use, in the United States, in the Mojave Desert, there's the Bright Source Solar Thermal System. This is the largest solar thermal power plant in the world. Currently, it can power up to 140,000 homes in California during the peak hours of the day. This facility will help to reduce carbon dioxide emissions by about 400,000 tons per year. It's located near the Nevada-California border, and it's comprised of 3 separate plants that were built in 3 phases between 2010 and 2013. Photovoltaic research at the National Renewable Energy Laboratory focuses on boosting solar cell conversion efficiencies, lowering the cost of solar cells, modules, and systems, improving the reliability of PV components and systems. Their scientists are pursuing critical activities that will help to accomplish the goal of the U.S. Department of Energy's Sunshot Initiative, which is to make large-scale solar energy systems cost-competitive with other energy sources by 2020. The R&D focuses on new materials, devices, and processes, measurements and characterization, performance and reliability, as well as engineering. Let's focus on the pros and the cons of photovoltaic cells. They're relatively expensive. They're intermittent in the sense that if there's no sunlight, there will be very little energy production. Energy storage is expensive, and photovoltaic cells are actually associated with pollution. During the production of photovoltaic cells, 80% of the silicon used is lost. Toxic chemicals are used in order to produce these cells, such as hydrochloric acid, and there's hazardous waste associated with photovoltaic cells, and they also require space. Now let's think about some of the pros. It's renewable energy, there's abundant sunlight, it's environmentally friendly, it reduces electric costs, it's silent, and there's financial support from the government and state. Low maintenance, and the technology is improving. So I decided to do this video outside because I wanted to sort of highlight the fact that sunlight is free and abundant, and photovoltaic cells offer a really good alternative to non-renewable energy sources. Thank you. My name is Quincy Greene, and I'm signing off.
So if you have any questions about photovoltaic systems or how to implement solar energy in your neighborhood, you can refer to these sources. From me and Quincy, thanks for watching.